Hi everyone, let's look at the LeetCode problem 1769. Minimum number of operations to move all balls to each box. You have n boxes. You are given a binary string boxes of length n. Okay, as you can see, you are given a string like this, where boxes of I is 0 if the ith box is empty. So that means here 0, 1, 2. So this is empty, 2 is empty, and 1 if it contains one bar. So here you can see, right, 0th index contain 1, 1th index contain 1. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to box, so you can actually in one go you can maybe like move from 0 to 1, or maybe like 1 to 0. Okay, that's why, because your ABS should be I minus j. Note that after doing so, there may be more than one ball in some boxes. Return an array answer of size n, where answer I is the minimum number of operations needed to move all the balls to the ith box. This is a very good question. Okay, now in this case, it's 1, 1, 0. What will happen is, if I move in one move, I could just move the ball in I is equal to 1 to 0. Then you will have both the balls in I is equal to 0. Similarly, you can do it the other way around. So that's why you see one operation is needed in both these cases. But now let's take this case where to index 2. If you see here, first this ball will have to move over here. So then that means here there will be two boxes. So that's one operation. Then in one of the operations, you can move one ball. So then that means you will need another two operations. That is to move both those balls to index 2. So if you see in total, you will need 3 operations, because you first moved the ball at 0th index to 1. Then from 1, you moved both the balls one at a time to 3. So you need 3. Okay. You can do this in an like order of n squared, where you take each index and see how far, like how many ones are there in different locations, and try to move over the balls and basically simulate how this works. And this will be very expensive, because it will be like roughly the best I think you can do it is in order of n squared time. But there is another way. So I hope you are aware of PrefixSum. So you can use PrefixSum here to do this calculation and provide an order of n solution. Now let me explain you how this PrefixSum approach will work. Now let's take this as our string. Okay, I just spaced it out so that it's very easy, and these represents each of these indexes. So how this works is, we will need to take a left PrefixSum and a right PrefixSum, and then the total should give us the number of operations needed. I can explain this very clearly. So if you see here, at this point, there is no ones to the left of 0th index. Okay, so let's imagine this is left. Okay, so now I come here. Okay, so at 1 also there is no zeros to its left. Okay, now to 2 also there is no zeros to its left, so there is no operation needed. So we can put for the left side. Now when I'm taking I as 3, then what happens is, if you see, I need one operation to get, I will also keep track of the number of ones here. Okay, so far it was 0. So now it has one operation to reach here. Okay, now let's come to 4. Okay, so here also there is no additional ones, but the other one which already took one operation here, for that one you need one additional operation to reach here. So that means it will be a 1 plus 1. Okay, so far so clear, right? The thing is, you had brought this one over here in one operation, and for that one, so your total one count is still 1. So for that to reach 4, you need another operation. So that means 1 plus 1, that will be 2. Now let's take this case. This is the trickier case. Okay, now we reached, so for this one to reach here, it took 2 operations. Now you need one additional operation to reach 5. So that means this is 2 plus 1. This is for just this one to reach 5, and then now you have one more additional one here. So that means you are going to have 2 ones here, and that will be +1. So that means you will have 4 operations, because you need one operation to move this one over to here. Okay, I hope this is clear. Now similarly, let's take right. If you see from here, there are 0 ones to its right. Now to reach here, now there is 1 1, so that has to come here. So for this one on its right to come here, you need 1 1. So initially I'll just reuse this variable. So now what will happen is this will be, if the total 1 count is 1. Now let's start with this one. So what, from 5 to come to 3, this one, so there is only 1 count here, that will take 2 operations, right? 1 plus 1, and then the one at 4 will need 1 operation to move here. So that means to reach 3, you need 3 operations. 2 operations for this one to come over here, and 1 operation for this one to come over here. So now the count is 2. Okay, now let's take this one. So here you have 2 ones which took 3 operations to reach here. So that means those 2 ones now has to take another 1 1 operations, that is 2 operations to reach there. So that means this will become 3 plus 2, 5. So far so good. Now so for this 2 ones to reach here, it took 5 operations. So now to reach 1, it will take 5 plus 2, because there are 2 ones. Okay, and then you also have a 1 from 2. So that means this will be 3 1 count, and that means you need 8 operations to be here. And finally, this 3 ones, it would take 8 plus 3 plus 0 operations. So that is 11. So you will see 11 operations here. And now let's find the total, right? So this will be 11. You just need to sum the left and right. So this will be 11, 8, this will be 5, this will be 4, this will be 3, and this will be 4. I hope this is clear. You can see, right? This is what you will end up with. And just a heads up, you can do it on the fly. So we can have this one optimized in such a way that your time complexity will be order of n, because basically it is order of 2n, which is equal to order of n, and your space complexity will be order of n, because you need a array. I will keep a ones count. Now what we'll do is we will first create a L array. Okay, I'll make it more small. Now for auto I is equal to 0, I less than you can start from 1, because at 0 you will not have anything. So we will start there. Now what we will do is we will just put LOP of I. So what we'll do is I'll just get the first 1 count here. So that is boxes of I equal to 1. Then what we'll do is, if it is equal to 1, we'll increment the 1 count. Okay, and LOP of I is equal to LOP of I minus 1. Okay, plus 1 count. This should be I minus 1. It should take the previous one. What we'll have now do is, I'll just keep the 1 count back to equal to 0. Okay, and now I'll try to find the right side. Okay, for the right one you just need an integer. You can just keep track of it and do the calculation on the fly. So we'll start with equal to 0. This will be boxes dot size minus 2. I don't have to consider the last index, and this will be greater than or equal to 0. I'll make this int. This will be here. Okay, so what we'll do is same way, if boxes of I plus 1 equal to 1, I'll just increment the 1 count. Okay, and then ROP is equal to ROP plus 1 count. Okay, and what we can do is we can use LOP itself to determine the total is equal to plus equal to ROP, and let's return LOP. See, looks good. This looks good. Okay, thank you. Hope this is clear. Have a good one.